Hi friends and my dear students, a very good afternoon to all of you. You all know chemistry is such a colorful subject wherein we find many chemical reactions, okay, and that too very colorful chemical reactions, isn't it? Okay, so many chemical reactions are existing in chemistry. Okay, in and around our surroundings also we find so many chemical substances and so many chemical reactions we find in and around our surroundings also, isn't it or not? Yes, it is very true. Chemistry is such a colorful subject that we really enjoy, okay, watching certain chemical reactions, that too colorful chemical reactions. Of course, some are colorless and some remains white, but there are many types of chemical reactions wherein we find very colorful chemistry and very colorful chemical compounds we will find. Okay, yes, this is your Lalitha Peri ma'am, your chemistry teacher, and in today's video we are going to learn about the topic. I think you can guess. Yes, what is the topic for today? Types of chemical reactions. Very correct, very true. You can all guess my point. Yes, the topic for today is what? Types of chemical reactions. Okay, types of chemical reactions. So what are the different types of chemical reactions? Okay, yeah, about that we are going to learn in this video. Yes, I just said there are so many types of chemical reactions are there. Okay, basically we find 4 types of chemical reactions. So first of all of you might have known already what is a chemical change. If 2 or more substances are combined with each other to give a new substance, okay, to form a new substance, which in turn we call them as what? Products. Okay, so such kind of chemical change, you call it as a chemical reaction. Okay, so there are 4 types of chemical reactions. How many types are there? Basically 4 types of chemical reactions are there. Okay, now, so what are those 4 types of chemical reactions? First we will learn about that, and especially in this video we are going to learn only about first type of chemical reactions, that is chemical combination reactions. Okay, so first let us learn the names of 4 types of chemical reactions, and totally in this video we will be learning only about what? Chemical combination reactions. Yes, so there are 4 types of chemical reactions. First one is what? Chemical combination reactions. Chemical combination reactions. Second type are what? Chemical decomposition reactions. Chemical decomposition reactions. And third type of reactions are chemical displacement reactions. Chemical displacement reactions. And fourth type are chemical double decomposition reactions. Double decomposition reactions. So there are 4 types of chemical reactions. So in this video we are going to learn about what? Chemical combination reactions. Okay, basically 4 types, and so many other types of reactions are also present, like exothermic reactions, endothermic reactions, combustion reactions, redox reactions. So many types of reactions are there, but all those reactions in one way or the other they comes under these 4 types of chemical reactions only. Okay, so we will start the video with combination reactions, and please all of you try to understand the concept very carefully, and at the same time you can watch how the compounds, different types of compounds look like with certain pictures in this video. Okay, so let us start now. So what are chemical combination reactions? Chemical combination reactions. Okay, so the reactions in which if two or more substances are combined with each other to form a single product. Okay, reactants can be many, but if the product is only one, then such kind of reactions comes under chemical combination reactions. And all such reactions, you can even call them as what? Synthesis reactions. Combination reactions can also be treated as what? Can also be called as synthesis reactions. Synthesis. Okay, now means to prepare. Okay, to prepare certain new products. So combination definition is what? If two or more substances combined with each other to form a single product. Okay, if two or more substances combined with each other to form what? To form single product. To form a single product, then such kind of reactions are called as single product. Such kind of reactions are called as what? Chemical combination reactions or synthesis reactions. Yes. Okay. In this, reactants can be many. Okay. Reactants, generally how an equation is represented? Reactants gives rise to products. Okay. Reactants can be one or more. Okay, now one or more. But product is only one. Single product. Okay, now only one product. Reactants can be many, but product is only one. Such kind of reactants, such kind of reactions are called as what? Combination reactions. Only one product. Okay, that can be formed either by heating or by just mixing two or more substances, by mixing an element and a compound, or by mixing two compounds, or by mixing two elements. We can get different types of products. Okay, we'll see several examples, then you will be understanding. It is like generally teachers will be giving examples like A plus B gives rise to AB. Okay, now where A and B are different reactants, they combine with each other to form a single product AB. Okay, generally we will give an identification. For understanding the chemical combination reactions, we will give like this. Okay, so let us learn the examples for chemical combination reactions. Okay, combination reactions are also called as what? Synthesis reactions. Examples for combination reactions. What are the different examples for combination reactions? Okay, that we have to learn now. What I said, two or more substances combine with each other to form single product. Okay, so simple examples I will just give you, and then we have to segregate these examples in the form of types, like element plus compound combination reactions. Element plus element gives rise to a new compound. Two elements can combine to form a single product. Two compounds can combine to form a single product. Okay, one element and one compound can combine to form a single product. Like that, we have different segregations are also there. That also we will be learning one by one. Okay, so for example, examples of combination reactions. First one, you can take it as what? C plus O2 gives rise to CO2. Okay, carbon. C stands for what? Carbon reacts with oxygen to form carbon dioxide. Okay, we are going to write upward arrow for gases. Carbon dioxide is a gas. You can even represent in the form of G also. Even oxygen is a gas. Carbon is a solid substance. Okay, when carbon is made to react with oxygen by heating, okay, by burning or by heating, you will be getting carbon dioxide gas. Will represent gases which are liberated, can be represented in the form of an upward arrow. Okay, so C plus O2 gives rise to CO2. It's an example for what? Combination reaction. reactants are 2, but product is 1 only. Okay, same like that. Sulfur plus oxygen gives rise to sulfur dioxide. Isn't it? Sulfur plus oxygen. Here sulfur is a solid substance. Oxygen is a gas. Okay, it gives rise to sulfur dioxide, another gas. Okay, so like this, 2 or more substances combine with each other to form single product. Then such kind of reactions are called as combination reactions. Okay, now we will learn these all examples by separate side headings. Okay, so what are the different side headings under which we learn different examples? Okay, we will be learning so many examples in this video. Okay, with different side headings. Okay, so let us start different examples. Okay, these are general examples which we will be learning from our childhood onwards. Okay, we will be learning now some different and higher standard examples also. Okay, so first type of combination reactions are what? I am keeping Roman letter 1. Okay, first type of reactions are reaction of metals with oxygen to form their respective oxides. Reaction of metals with oxygen. This is the first side heading under which we will be learning different examples. Okay, so reaction of metals with oxygen to form their respective oxides. To form their oxides. Okay, this is the side heading. Reaction of what? Metals. Metals react with oxygen to form what? To form their respective oxides. Okay, we will learn certain examples for this. So first example. Okay, first example is what? Magnesium ribbon. Okay, 2 Mg plus O2 gives rise to 2 MgO. 2 Mg plus O2 gives rise to 2 MgO. Here Mg stands for magnesium ribbon, burns with oxygen and forms magnesium oxide. Okay, magnesium oxide, MgO means what? Magnesium oxide. Here a very important point you have to learn. What is that? Here magnesium ribbon. Mg stands for what? Magnesium available in the form of a ribbon. You can see that in the picture. Okay, magnesium ribbon burns with oxygen. Okay, it's what type of reaction? Anywhere reaction with oxygen means what? You are burning that particular substance. Isn't it or not? You are burning that particular substance. Okay, here magnesium ribbon is burnt. When it is being burnt, it gives out a dazzling white light. Please remember this point, very important. Which metal burns with dazzling white light? Means what you will be writing? Yes, magnesium ribbon burns with dazzling white light. Okay, and forms a white colored ash, which is called as what? Magnesium oxide. It is a white colored ash. White ash will be formed. Okay, magnesium oxide. Okay, you can see that in the picture. Okay, dear children. So, please remember, magnesium ribbon. Write that as a note point. Note. Magnesium ribbon, Mg ribbon, burns with a dazzling white light. Okay, burns. Burns with dazzling. Okay, burns with what? Dazzling white light and forms what? Magnesium oxide. It's a white colored ash. Burns with a dazzling white light. Dazzling white light and forms white ash of MgO. Okay, do you remember in olden days this magnesium ribbon, burning of magnesium ribbon is very much useful for rescue operations of ships. Do you know that? See, when a ship is in danger, or if they want any kind of rescue operations, they used to give signals with the help of this magnesium ribbon only. Okay, because it burns with such a high intensity that the light coming out from that magnesium ribbon can be visible from very long distance also. Okay, the persons, those who are in the middle of the ship, okay, sailing boats and all, okay, during night times, if they burn magnesium ribbon, that light coming out from that magnesium ribbon will be visible to very long distance, and that will be an indication that that particular people, those who are in that particular ship, are in want of some rescue operations. So as soon as such kind of indication, if it is given, then immediately from shore, okay, some rescue operations will be taken, and some other ships will be sent for rescue. So such a dazzling white light magnesium burns with. Okay, so that's why it is very important point you have to note down. Okay, magnesium is a metal. It burns with oxygen to form what? White colored ash, magnesium oxide. And this magnesium oxide, okay, will be a white colored ash, as I already told you. If this ash is collected in a China dish, okay, now MgO plus H2O, if you are going to add water to it, okay, then it forms what? Magnesium hydroxide, MgOH taken twice. Okay, magnesium oxide made to react with water. You collected that ash in a china dish and you are adding water to that magnesium oxide. Then it forms what? Magnesium hydroxide. Okay, now magnesium hydroxide. Okay, so this is highly basic in nature. Basic. Okay, now this is highly basic in nature. This basic substance generally turns what? Generally turns, yes, you can even know about the litmus test. Okay, if it is a basic substance, all basic substances will turn what? Red litmus to blue. Okay, red litmus to, it converts red litmus to blue. Okay, or it can even convert phenolphthalein indicator. Do you know about that? Yes, phenolphthalein is a kind of synthetic indicator. It turns phenolphthalein indicator to pink color. Okay, phenolphthalein is a colorless substance, and this magnesium hydroxide is also a colorless substance. Okay, as you added it to water, then it is magnesium hydroxide. It's a colorless substance. Okay, when phenolphthalein is added, okay, turns phenolphthalein to which color? To pink color. Turns phenolphthalein indicator. What is phenolphthalein? Phenolphthalein is a synthetic indicator which is used to identify whether the given substance is acidic or basic. For basic substances, it turns to pink, and for acidic substances, it remains colorless. Okay, you will be learning about this in acids and bases also. Okay, so basic substance, it turns phenolphthalein to which color? To pink color. If it turns to pink, then you can say that the so formed substance is a basic substance. Okay, so this is also an example for what? Combination reactions. Okay, second example this is, right? As I was speaking about magnesium, so I just continued with this. Okay, please take down the reactions. Okay, next we'll go for the next metal. What I was keeping the heading, just recall. Reaction of metals with oxygen. I gave only one example. Okay, now we will be learning the next example. Example 2. Second metal which reacts with oxygen to form its respective oxide. Okay, see here. Example 2. So what is that? You can take lead reacts with oxygen to form lead oxide. 2 Pb plus O2 gives rise to what? 2 PbO. 2 Pb plus O2 gives rise to 2 PbO. What is PbO here? Lead oxide. Lead oxide. Okay, now lead monoxide. Okay, it is generally appearing to be yellow in color. It can even appear in the form of orange color also, or you can also call it as red lead oxide. Okay, lead oxide generally we'll found it to be in which color? Yellow color. Okay, and appears sometimes will be available even in orange color also. Okay, orange also available. Okay, you can see that in the picture. So 2Pb, here reactants are 2, but product is 1 only. Such kind of reactants are called as what? Reactions are called as combination reactions, isn't it? So 2Pb plus O2 on heating. Do you know this symbol? This triangle symbol on the gives rise to arrow. Like this, on the gives rise to arrow. If you find a triangle symbol, okay, then it is called as, you have to read it as what? On heating. Yes, on heating. It gives rise to lead oxide. And what is the color of lead oxide? Yellow. And it can be available in the form of orange, or you can also call it as what? Red lead oxide. Lead is a metal reacting with oxygen. Metals with oxygen to form their oxides. Okay. So this is one example. Similarly, you can take the example of copper and zinc also. Okay, copper. See here, example 3, you can take copper Cu plus 2Cu plus O2 gives rise to 2CuO, copper oxide. Okay, now this is what? Copper oxide. And copper oxide will be black in color. Please remember this point. Color changes also are very, very important. Okay, copper. You know the color of copper. Copper metal. Okay, copper metal when made to react with oxygen, it forms copper oxide, and color of copper oxide is what? Black in color. Color changes you have to remember. Must it is. Okay. Same like that. We'll take the example of zinc also. Zinc. 2Zn plus O2 gives rise to ZnO. 2Zn plus O2 gives rise to what? Zinc oxide. 2ZnO. 2ZnO. And this ZnO will be yellow in color when it is in hot condition, and it when it is cooled it turns white only. Okay, yellow. Zinc oxide will be yellow when it is hot. Under hot conditions, zinc oxide will be yellow in color. Once it is cooled, then it turns to white color. Okay, so color changes, please remember. Zinc is a metal reacting with oxygen to form what? Zinc oxide. All these are basic oxides only. Even magnesium oxide, lead oxide, copper oxide, zinc oxide, all these are what? Basic oxides. Okay, we'll focus on acidic and basic oxides and all in the chapter of acids and bases. Okay, so please remember the color changes here. Okay, same like that, even sodium metal can react with oxygen to form sodium oxide. Potassium can react with oxygen to form potassium oxide. And you know, potassium and sodium, these two metals are what? Highly reactive metals. Very highly reactive metals. They readily react with oxygen or with water to form their respective hydroxides. Okay, they are very highly reactive metals. Okay, so this is you can even take that also as an example for what? Combination reactions. Okay, see here, sodium and potassium, very important. Okay, sodium and potassium are what? Very highly reactive metals. Okay, we'll take example 5, potassium. K plus O2 gives rise to 4K plus O2 gives rise to 2K2O. This is potassium oxide. Okay, now potassium oxide. Potassium oxide. It is also a combination reaction. This potassium oxide, when made to react with water, okay, 2K2O plus H2O gives rise to 2KOH. Okay, KOH, highly reactive. Okay, potassium is what? Highly reactive metal. Vigorous reaction will take place. Okay, now very highly reactive. KOH is what? Potassium hydroxide. It is also a combination reaction. Okay, now potassium hydroxide. Even this is also what? Basic in nature and turns phenols into pink color. Same like that, you can even write the same kind of reaction with sodium also. 4Na plus O2 gives rise to 2Na2O. Okay, this is what? Sodium oxide. This is also basic in nature. And when made to react with what? Okay, this is 4KOH, I hope. Balancing, I am not focused here. 4 potassiums, 2 plus 1, 3 oxygens. Okay, yes, if I keep 2 here, the equation is balanced. 4 potassiums, 4 potassiums. 2 plus 2, 4 oxygens, 4 oxygens. 4 hydrogens, 4 hydrogens. The equation is balanced. Okay, same like that, you can even write with sodium also. You can see in the picture how much reactive potassium and what we call sodium are highly reactive metals. Okay, we have lot much to focus on this reactivity of sodium and potassium in displacement reactions also. Okay, such a vigorous reaction, they immediately catch fire. Okay, and gives fire, burning, it keeps burning. Okay, it catches fire and immediately it starts burning even in water also. Sodium is such a highly reactive metal. Okay, it catches fire in water. Please understand the point carefully. Okay, so 2Na2O, when made to react with water, H2O, it gives rise to 4NaOH. Okay, this is what? Sodium hydroxide. Okay, sodium hydroxide. These are also combination reactions only. Reactants are many, but product is one only. One type of product. Okay, one type of product only is formed. All such kind of reactions are what? All these are examples are first type, where metals are made to react with oxygen to form their respective oxides. Okay. Please pause the video and note down all these examples. Okay. Yes. Next we'll move on to the second type of examples, where reaction of non-metals. Okay, reaction of second Roman I am taking now. Okay, second type of examples. Second type of combination reactions, Roman number 2. Okay, reaction of what? Non-metals. Reaction of non-metals with oxygen. Reaction of non-metals with oxygen to form their respective oxides. Okay, so let us learn with examples. Non-metals with oxygen. Okay, so let us take the first example of non-metal with oxygen. Okay, so just now first example which I have already dealt is what? Carbon is a non-metal. You all know that. Reacts with oxygen to form what? Carbon dioxide. Yes, carbon, solid substance. Okay, when made to react with the oxygen gas. Made to react with oxygen means what? Yes, you are burning that carbon powder. Sorry for the disturbance, I am coughing. Okay, oxygen to form what? Their respective oxides. Here carbon dioxide. Okay, it is formed. It's a colorless gas. Okay, you all know that it is a colorless gas. And you all know that carbon powder appears to be black in color, like coal powder. Okay, now coal is rich source of what? Carbon only, no? So carbon powder appears to be like black color. You can see that in the picture. Grayish black colored substance, carbon. Okay, when made to react with oxygen means what? When it is burnt, okay, it gives carbon dioxide gas, which is a colorless gas. Okay, next we'll move on to the second example, which is a very, very important example. Sulfur plus oxygen gives rise to sulfur dioxide. See here, sulfur powder. sulfur powder is what? Yellow color. Yellow colored sulfur powder. You can see that in the picture. Okay, yellow colored. Sulfur powder appears to be like what? I used to say to my students, it appears to be like what? Complan Kesar Badam. Yes, all students know the color of Complan Kesar Badam, isn't it? It appears to be yellow in color. Okay, so when I was showing the sulfur powder to my students and I was telling about this color of Complan Kesar Badam, okay, very nutritious drink, okay, which all children like, isn't it? I think you also like that. Not only children, even elders also like to drink badam milk, isn't it? It appears to be yellow in color. You can see that in the picture, right? Sulfur powder appears to be yellow in color. Okay, when need to react with oxygen, okay, on heating. This is also on heating. This small triangle on the gives rise to arrow indicates what? On heating, it gives rise to sulfur dioxide gas, and sulfur dioxide is a colorless gas. Okay, and here you write a note point. Sulfur powder, sulfur is a non-metal. Sulfur powder, yellow color it is. Okay, and when it is burning, okay, it gives you blue colored flame. Okay, please write that as a note point. Note, sulfur burns with a blue flame. Sulfur powder burns with a blue flame. Okay, blue flame, and gives sulfur dioxide gas. Okay, and you know about this sulfur dioxide? Very peculiar gas this is. And even sulfur dioxide, when made to react with oxygen, it gives rise to sulfur trioxide also. Okay, now 2SO2 plus O2 gives rise to 2SO3. 2 sulfurs, 4 plus 2, 6 oxygens. Here also 6 oxygens. This is also on heating only. Okay, so this is also even a combination reaction. Sulfur dioxide, when made to react with excess oxygen, it will give what? Sulfur trioxide gas. Okay, that is also even a colorless gas. But here, you know, this sulfur dioxide also acts as a very good bleaching agent. Okay, so that also you write it as a note point. Sulfur dioxide acts as a very good bleaching agent. What is bleaching agent? Note, SO2 acts as a very good bleaching agent. Okay, what is this bleaching agent? Okay, means what? Suppose if any vegetable coloring matter is exposed to sulfur dioxide gas, okay, then it renders colorless. Okay, what I mean to say, please understand the point carefully. When any vegetable coloring matter, any colored flower or any colored vegetable, if you are exposing that to the sulfur dioxide gas, then it makes that colorful flower to become colorless. A rose flower, a red rose flower, if you bring and expose that to sulfur dioxide gas, then all the petals of the rose will turn to white. That means what? It is a very good bleaching agent. Okay, it bleaches the colors, the vegetable coloring matter that is present inside the flowers as well as some vegetables also. Colored vegetables like carrot, beetroot. Okay, so small pieces of vegetables of carrot, beetroot, any colored vegetables, if you bring them and expose them to sulfur dioxide gas, then they become colorless. Okay, so if it becomes if they become colorless, then you can say that particular substance as dehydrating agent or bleaching agent. That means it absorbs off the water molecules from that particular flower. Okay, bleaches, it bleaches the flower. You can see that in the picture. Okay, it bleaches the flower. That's why sulfur dioxide acts as a very good bleaching agent. Okay, please remember this point. And here even this sulfur trioxide, when made to react with water, okay, it forms sulfuric acid, H2SO4. what is what? What is this? Sulfuric acid. This is also a combination reaction only. Isn't it or not? Yes. Okay. 2 sulfurs. Maybe I have to keep 2 here. 2 sulfurs, 6 plus 1, 7 oxygens. Here 8 oxygens are there. I have to keep 2 here. Okay. Let us see. 4 hydrogens, or directly it can be 2 sulfurs, 6 plus 2, 8 oxygens. Here also 8 oxygens, 4 hydrogens, 4 hydrogens. So all are having 2's. So directly you can write SO3 plus H2O gives rise to H2SO4. Okay, it's a sulfuric acid. Okay, so this is also a combination reaction. So please remember the note points regarding sulfur. You will be getting them in objectives. Color of sulfur powder is yellow. Okay, sulfur dioxide will be formed on heating sulfur powder, and sulfur powder burns with which colored flame? That also you might have seen in the picture. Yes, sulfur powder burns with blue flame. Okay, and gives sulfur dioxide. Sulfur dioxide is a colorless gas, but it acts as a very good bleaching agent. That means it renders the vegetable coloring matter, it renders that to be colorless. Okay, so that is the speciality of sulfur dioxide. That's why it is called as what? Bleaching agent. Okay, or you can even call it as dehydrating agent. Okay, so that is one thing. So we are discussing about what? Non-metals. Non-metals with the oxygen. Okay, here one more example also you can come across. Phosphorus. Okay, phosphorus reacts with what we call oxygen. Phosphorus, third example this is also a very important example. Phosphorus, when made to react with oxygen, it forms phosphorus pentoxide. P4 plus 5 O2 gives rise to 2P2O5. This is what? Phosphorus pentoxide. Phosphorus pentoxide. Okay, here also one interesting factor I have to tell you about. Okay, that's why please, my dear children, please, without skipping the video, please continue to watch the video until the end, because you will be getting lot much information. Okay, in this video, lot much information. Okay, so that's why, and it will be very interesting also, isn't it? Look at this example. P4 plus 5O2. P4 is what? Phosphorus. Okay, phosphorus, when made to react with the oxygen, it forms 2P2O5. Here also you will be getting one very important note point, which this reaction you call it as phosphorescence reaction. What is that? Phosphorescence. The reaction is called as what? Phosphorescence reaction. Okay. Note. This reaction is called as what? Phosphorescence reaction. Is called as phosphorescence. Yes, CNC, phosphorescence reaction. Okay, so what does it mean? Okay, you will be coming across certain times. Before I say about this, you all should know that our bones consist of what? They are rich source of phosphorus and calcium, isn't it or not? Even our teeth also, our bones also are made of what? Calcium phosphate. They are rich source of phosphorus and calcium. Phosphorus is present in our body, in our bones. Okay, so what is phosphorescence reaction? Means, suppose when a dead body is burnt, please listen to my point very carefully. When a dead body is burnt, okay, after it is completely burnt, sometimes you will observe a kind of flashlight coming out from that dead body. Okay, most of the people will be thinking that it is some kind of evil effect, or some ghost is there coming out from that dead body, something like that. No, nothing is there. The phosphorus present in our bones comes out and immediately reacts with atmospheric oxygen and forms this phosphorus pentoxide, and this phosphorus pentoxide appears to be like a flashlight in graveyards. Okay, please understand the point carefully. Phosphorus pentoxide appears to be like a flashlight in graveyards. Okay, P2O5 appears to be like a flashlight. Okay, appears to be like a flashlight in graveyards. Okay, so in that's why that glowing phosphorus, okay, gives the phenomenon of what? Phosphorescence. Okay, please remember this point. Phosphorus is a highly reactive non-metal. Please remember that point also. Highly reactive non-metal. Highly reactive metal is what? Potassium and sodium. Those two are highly reactive metals. And in case of non-metals, phosphorus is a very highly reactive non-metal. Okay, so phosphorescence reaction. This is called as what? Phosphorescence reaction. Okay. So this is also an example for a non-metal, reaction of non-metal with oxygen. Similarly, nitrogen is also one of the non-metals which is present. It's a gas. You all know that. You can take the example. Fourth example of non-metal is what? N2 plus O2 gives rise to 2NO, nitric oxide. Okay, nitric oxide. Okay, so many like that. Even nitric acid is also formed when this nitric oxide is made to react with water, and that also comes under combination reaction. Okay, so this is also one of the examples for what? Combination reactions. Now we'll move on to the third category of combination reactions. So what are those? Third category. Okay. Reaction of metals and non-metals with chlorine to form their respective chlorides. Okay. Third category. Reaction of metals and non-metals with chlorine. Metals and non-metals. Both examples we will be discussing in this only, in this side heading only. Okay, reaction of metals and non-metals with chlorine to form their respective chlorides. To form their respective chlorides. This is your third side heading. Okay, metals react with chlorine to form that metallic chloride. Okay, similarly non-metals also. We'll take one or two examples for this. So what are the examples to form chlorides? Suppose if you take sodium metal, 2Na plus Cl2 gives rise to 2NaCl. Sodium chloride, common salt. Okay, now this you know. Common salt. Okay. Sodium chloride is a common salt. Sodium is a metal reacting with chlorine to form sodium chloride. Okay. Same like that, 2H2 plus Cl2 gives rise to 2HCl. Hydrogen chloride. This is what? Hydrogen chloride. Okay. Hydrogen is a non-metal. When made to react with chlorine, it forms what? 2HCl. Hydrogen chloride. Okay. Same like that, copper. I will write one more example for that. Copper. Copper is a metal. You know that. Copper plus chlorine. Cu plus Cl2 gives rise to CuCl2. Cupric chloride. Okay, now this is what? Cupric chloride. Okay, cupric chloride will be blue in color. Copper salts. Most of the copper salts are which colored? Yes, you have to remember the colors. Copper salts all are blue in color or bluish green in color. Okay, here cupric chloride is which colored? Blue in color. This is also an example for what? combination reactions. Reactants are 2, product is 1 only. Okay, copper chloride, formation of copper chloride. Okay, now let us move on to the fourth type, fourth side heading. What is that? Fourth type of reactions. Reaction of elements to form their sulfides. Formation of sulfides. Okay, formation of sulfides. Remember this, sulfides. Okay, so let us learn about this. Okay, first example you can take Fe plus S gives rise to FeS. Okay, Fe plus S. What is Fe here? Iron. Iron powder. Okay, when made to react with the sulfur powder, okay, then it forms what? FeS, ferrous sulfide. Okay, colors. You can we already discussed the color of sulfur powder. Complan Kesar Badam color means what? Yellow color. Yes, sulfur powder is yellow in color. Ferrous sulfide is what? Grayish black colored substance. FeS, ferrous sulfide. It is what? Grayish black colored substance. Please remember. Okay, grayish black. Grayish black colored substance. FeS. Okay. Same like that, zinc sulfide you can take. Zinc sulfide. ZnS. Zn plus S gives rise to ZnS. Zinc sulfide. Okay, it's a white colored substance. Zn plus S gives rise to ZnS. What is ZnS? Zinc sulfide. White colored. Okay, same like that, Pb plus S gives rise to PbS. Okay, PbS. What is this? Lead sulfide. In the form of ore, you call it as galena. Okay, if it is available in the form of ore under the earth's crust, you call it as galena. But in the form of a powdered sulfide of lead, you call it as lead sulfide, and it will be appearing white in color. Lead sulfide. Okay, now PbS means what? Lead sulfide. Okay. Okay, lead sulfide. Okay, this lead sulfide will be black in color, and this when made to react with what? Oxygen. This lead sulfide when made to react with oxygen, it forms lead sulfate. That is also an example for combination reactions. Okay, PbS plus O2 gives rise to PbSO4. Okay, now PbSO4, which is called as a lead sulfate. Lead sulfate is what? White colored substance. Okay, so these all are examples of what? Formation of sulfides. And here we have observed the formation of sulfate also. Okay, and then we'll finally move on to, okay, finally move on to reaction of certain elements to form nitrides. Okay, please take down, pause the video and note down all the equations and reactions with color changes. Okay. Yes, next, fifth side heading and the last one. Okay, formation of nitrides. Formation of nitrides. Okay, we'll see certain examples. First example, okay, N2 when made to react with hydrogen, Okay, it forms ammonia, NH3. N2 plus 3H2 gives rise to 2NH3. Okay, this is what? Ammonia. Nitride of hydrogen, this is ammonia. Okay, nitride of hydrogen. Hydrogen, when made to react with nitrogen. Nitrides, how they form? When any substance is made to react with nitrogen, it forms their respective nitrides. Okay, so ammonia is a nitride of hydrogen. Okay, how does this ammonia is formed? Okay, on heating only. Okay, on heating the nitrogen with hydrogen to almost at a temperature of 400 degrees centigrade, above 400 also. Okay, 400 degrees centigrade, and a very high pressure of almost around 500 atmospheres pressure. Okay, you have to give pressure, compress. Okay, then you will be getting ammonia. Okay, these are the conditions, temperature and pressure you are giving for the formation of what? Ammonia. Okay, and this you call it as Haber's process. This process you call it as what? Haber's process of making ammonia. Haber's process, please remember. Okay, ammonia is a nitride of hydrogen. Please remember that point. Okay, this is also a combination reaction. Here reactants are 2 and product is 1 only. Okay, second example, calcium nitride, magnesium nitride. You can take Ca plus N2 gives rise to 3Ca plus N2 gives rise to Ca3N2. Calcium nitride, this is calcium nitride. Same like that, even you can write magnesium also. Here only I am writing 3Mg plus N2 gives rise to Mg3N2. Magnesium nitride. Okay, now magnesium nitride. Okay, so these are also the examples of what? Combination reactions. Okay, so in all these reactions you will be finding several examples, as I already told you. Okay, and one more very important, most commonly asked example is what? Star. Teacher kept star, means very important example teacher is giving. Okay, calcium oxide when made to react with water, same like as how we discussed for what we call magnesium oxide. When made to react with water, it forms its magnesium hydroxide. Respective hydroxides will form. Here also calcium hydroxide will form. CaOH taken twice. Calcium oxide is called as what? Quicklime. Calcium oxide is called as quicklime, whereas calcium hydroxide is called as slaked lime. Okay, now slaked lime. Okay, lime water. You can even call it as what? Lime water. This calcium hydroxide, okay, when made to react with excess CO2, okay, then when made to react with CO2, okay, then it forms what? Calcium carbonate. A white colored precipitate will form. Okay, white precipitate. This is not a combination reaction, but you have to remember this. It is a precipitation reaction which comes under double decomposition reactions. Okay, but this is most of the cases they are asking this example. That's why I just told you. Okay, this is a precipitation reaction, PPT reaction. Okay, and along with that it gives out water also. Okay, here you have to remember very important thing. This CaO reaction with water, okay, is highly exothermic reaction. Okay, highly exothermic means what? Releases heat energy. What are exothermic reactions? We'll be discussing that in a separate video. All exothermic and endothermic reactions with different examples, as how now we were learning about combination reactions. Same like that we will be learning exo and endothermic reactions with several examples. Okay, it's a very highly exothermic reaction. Means what? The reaction which is associated with release of heat energy are called as what? Exothermic reactions. So it's a very highly exothermic reaction. Okay, it gives out a lot of heat energy, and you will also find a hissing sound. Okay, hissing sound when water is reacting with calcium oxide. You can find the hissing sound. Okay, you can even observe this when you are seeing that pan, when you are making pan. Okay, betel leaves, on betel leaves we will applying tuna. You all know about tuna. Okay, that is calcium oxide. When made to react with water, you will find a hissing sound. Or here also you will be getting certain important questions, especially daily life application questions for children of class 10. What kind of questions are being observed? Means during whitewashing of walls. In olden days, we used to do whitewashing of walls. Chuna lagana. Okay. Diwar ko chuna lagana. Okay. So while whitewashing of walls. Okay. So we will find after it gets whitewashed, after some time, okay, the wall appears to be more shiny and bright white. Why it appears like that? After it gets dried, it appears to be more white, more shiny. Okay, the wall appears. When it is in wet condition, you will not find it to be crystal white. But after it gets dried, the wall appears to be more white, bright white and shiny. Why it appears like that? Because of the formation of calcium carbonate. That's what I am saying. Calcium oxide, when made to react with H2O, it forms calcium hydroxide. Okay, that means on the wall you painted calcium hydroxide. That calcium hydroxide absorbs atmospheric carbon dioxide. It absorbs atmospheric carbon dioxide and forms a white precipitate of what? Calcium carbonate. What is precipitate? Precipitate is an insoluble solid substance which settles down at the bottom of the test tube when two or more substances are made to react with each other. Okay, you will be learning about that in double decomposition reactions. Okay, precipitation reaction comes under double decomposition reactions. You will be learning about it. It's highly exothermic reaction and it's a precipitation reaction. Okay, after whitewashing, the walls appear to be more shiny and bright. This is a very important question which you will be coming across in daily life examples. Okay, after whitewashing of walls, they appear to be more shiny. They appear to be more bright and shiny. Because of the formation of CaCO3. Because of, I think you can able to see if I write here, because of the formation of CaCO3. Very, very important note point this is. Okay, most of the times in the exams, okay, they are focusing on what? Daily life application questions. Okay, so you have to focus more on daily life application questions. All these examples which now we have dealt with are daily life applications only. Okay, so this is also the best example for what? Combination reactions. Okay, so more and more examples about different other types of chemical changes we'll be learning in the next coming videos. Until then, I would like to request all of you to kindly visit my channel, watch all my videos. Okay, you will find a kind of speciality in my videos. My teaching completely will be in English. Okay, and sometimes I may use Hindi words because YouTube is a channel which goes for all over the world. Okay, so whatever it may be, my language has to be understood by all of you and I should be liked by all of you. Okay, so please kindly subscribe to my channel, share my videos to your friends. Okay, tell them that Lalitha ma'am is uploading very nice videos colorfully with pictures and all, okay, and a very best explanation. I expect comments from you, okay. Your comments, your likes are a very big support for teachers like me, okay. So please support me in my journey. Kindly subscribe to my channel, okay. Always keep learning and learn happily, okay. Happy learning, okay. Thanks for watching. Bye.